now I can define my triangle as saying that the adjacent is 2x and the hypotenuse is 1. And for the tangent then, tangent of the angle theta, I have to figure out what the opposite is, and then of course the tangent theta is the opposite over the adjacent. So eventually I'm going to have something written as, here's the fraction bar, the adjacent I already know that is 2x, and the opposite here is, well, by the Pythagorean is going to be, I'm going to move this over here a little bit, a little more space. Opposite equals the hypotenuse squared minus the adjacent squared. So 4x squared, 1 minus 4x squared, and take the square root of that. And there, when I take the square root, I can say I have a positive or a negative number, but then the problem it says assume the variable represents a positive number. So I'd use a positive square root, and I'm going to come up with that the opposite is 1 minus 4x squared. Take the square root. So basically, really what I did here is I followed what they're telling me here in a couple of examples in that chapter, and now I'm going to see that indeed one of the answers is that particular one. Okay, problem 19. Rewrite the expression as a sum or difference, then simplify as possible. So 4 sine 7x cosine 2x, and I have to write as sum or difference. It can be argued if it looks more simple when I'm done or not, but that's what this particular problem wants me to do, so it's supposed to look like one of these here. And again, it could be argued if that looks simpler, but that's what it wants me to do, to change it to such. So sine 7x cosine 2x, which is going to be this one here, so that's what I'm going to use, and of course the 4 is just going to be in the front. And don't necessarily look at that this one here or this one is correct, because notice there's a divide by 2, so if I happen to have a factor 2 in there, that could actually divide out. We'll see what happens. Okay, anyway, I'm going to use this one here, and again I need to push it to the side. And number 19 is going to be 4 sine 7x cosine 2x, and then I'm going to use those product to sum identities, and sine cosine is going to be, need the fraction bar first, is going to be sine 7x plus 2x plus sine 7x minus 2x divide by 2, and then I forgot that 4 there, so there it is. And if I really wanted to, I could make that a proper fraction bar, and then 4 over 2 is 2, and then I'm going to have parentheses sine of 9x plus sine of 5x. Okay, so what I did here is I used this one here and just plugged in my 7x, 2x, 7x, 2x, and I come up with, what was it again? 9x plus 5x. Yep, there's sine 9x plus sine 5x, and there it is, except they wrote it. Well, they exchanged the two, but of course addition is commutative. So problem 20. Rewrite the expression as sum or difference, then simplify if possible. Well, cosine 90 is actually 0, cosine 270 degrees is actually 0. So I know the answer right away, but what they want me to do is use this particular one right there, cosine, cosine, and then so on. And this is what I would come up with. This is actually the long way of doing this particular problem. And they don't say that I have to do it this way, but I'm guessing, it was just the just a problem ago, the product to sum formula was introduced, so at this point here, that's what I should be using. That's the product to sum formula. Again, it says cosine 90 degrees plus, whoops, cosine 270 degrees, no, times cosine 270 degrees. And that comes out to fraction bar cosine 90 minus 270 plus cosine 90 plus 270 divide by 2, and that equals then cosine of negative 180 degrees plus cosine of 360 degrees, fraction bar divide by 2 equals negative 1 plus 1 divide by 2 equals 0. And the last problem, number 21, I'm supposed to figure this one out here with a sum to product formula. And so this one is going to be 21 cosine 5 pi over 12 minus cosine pi over 12, and for that one I have to use this one here, and so I'm going to use that and just plug everything in. So that's going to be negative 2 sine of 5 pi over 12 plus pi over 12 divided by 2 times sine 5 pi over 12 minus pi over 12 divided by 2 parentheses equals negative 2 sine, that's going to be 612 divided by 2, which is going to be 6 over 24, so it's a quarter, pi over 4, and this one is going to be sine, that's 4 over 12, so 4 over 24, which is pi over 6. That's the answer, and that particular one is going to be, okay, I see what happens. All right, so negative 2, and then sine pi over 4 is the same as sine of 45 degrees is the square root of 2 over 2. I see, okay, and this one here is sine 30 degrees, which is 1/2. And so one of these two divides, and I'm going to have negative square root of 2 over 2. And that one is, which one? Did I do this too quickly? Oh, it's the first one. There we go.